I have physics. I've always had an interest in physics. And for one example, one of my favorites is one called quantum fluctuations. This is a quantum mechanic segment from the series where it's a change of energy within an area. And to put it down, basically means matter can be created out of nothing, because nothingness in itself is a unstable event. You can't have nothing. Nothing is like void. You can't have void because, let's say you had your own pocket dimension, all to your own control, and there's nothing there. No particles, no nothing. How can that even possibly be? There has to be something. So that's what quantum fluctuations is. It's a theory created by scientists to give an understanding of possibility of Big Bang and also how matter and everything works and comes together. Matter can be created out of nothing. Another one would be absolute zero. This is another one of my favorites due to the fact because it's such a it's a concept idea that there's many possibilities that could go with it. Absolute zero is the freezing point where atoms and the electrons, protons, neutrons stop moving when you freeze it to a temperature. It's negative 273.15 degrees Celsius and 0 degrees Kelvin. At absolute zero, atoms, the reason why they stay together is because electrons rotate around the proton and the neutrons, which is the nucleus, giving the atom its structure. Now, if the electrons were to stop moving, what happens to the atom? Does it fall apart? One theory is that the protons, neutrons, and electrons separate and fall apart. Another one is a singularity is created. A singularity is another name for a black hole or any form of critical event. But the thing is about absolute zero, it's practically impossible to reach. There's energy everywhere in this world. That's why matter is created. That's why we're here. That's why the universe exists. So the fact that energy is everywhere, you can't ever really reach it because energy provides heat, so you can never actually get anything down to zero. Last one is gravity waves. Ben talked about this very quickly in his presentation. And what this is a theory that was created by Einstein in the 40s. And with this theory is that gravity waves is a form of energy, of gravitational energy that cannot be detected, seen, heard, or even detected directly. The only reason why we, as of now, of 2015, mainly with more in-depth research, is due because an indirect science experiment. We were watching and analyzing light particles. And we did this up in space in a satellite. We were measuring the light particles in a very, very complex system to measure the smallest and smallest of movements. Now, what we detected was that gravitational waves moving across space and time move these particles in just tiny bits of distance, just enough to be detected. With this is we reverse engineered to see what happened and why they moved, and what we detected is that we were feeling gravitational waves from stars and black holes from billions of years ago, because gravitational waves are equivalent at speed to that of speed of light, the fact that they have no mass and they have nothing really to restrict them. Now, with all these theories, you can tie a lot of things to them. The scientists and how they had ingenuity, engineering degrees, problem solving, critical thinking, and teamwork. These are all aspects that we are learning here at Met. All these aspects go into these groundbreaking theories that come to the creation of the universe in itself, and the creation of us. At Met, these aspects is the reason why we've learned these things, why we've gotten this so far ahead in humanity as we have. With MET, we are going to be the future for all future aspects of life, all future theories, science, breakthroughs, anything that is to come and to be. It's going to be put on our shoulders now. So everything that comes forward will be with us.